Recall last time we learned that the inverse sine of the sine of x equals x as long as x was between negative pi over 2 and pi over 2 inclusive. Likewise, sine of the inverse sine of x equals x as long as x was between negative 1 and 1 inclusive. The same thing goes with cosine and tangent. What happens, however, if x is not within the given domain? How do we handle this situation? That's what we're going to look at today. Alright, so let me start us off with an example. Okay, let's look at the inverse sine of the sine of 5 pi over 4. Notice 5 pi over 4 is not in the domain negative pi over 2 to pi over 2 for the inverse sine of the sine. So, to handle this, what we do is we go to our table and we find the sine of 5 pi over 4. Okay, looking at our table, we find sine of 5 pi over 4 to be negative square root of 2 over 2. So now we have the inverse sine of negative square root of 2 over 2. Now, we're going to find the angle whose sine is negative square root of 2 over 2. That is negative pi over 4. Okay, if we look in our table, we find a value or two that has negative square root of 2 over 2 in the sine column. However, okay, it is not between negative pi over 2 and pi over 2, which is the domain for our function. Therefore, we take the one that most closely fits and we subtract 2 pi from that. That gives us negative pi over 4. Now, what happens if the given value is not in our table? Well, let's take a look at an example or two of this situation. Let's find of the inverse tangent of 1/2. Oops, let's see. The inverse tangent of 1/2. Okay, for this, we're going to draw our quadrants. Okay, now, we're going to take the sine of this. Okay, theta is between negative pi over 2 and pi over 2 for the inverse tangent. Okay, so that means that we're either in the first quadrant or the fourth quadrant. Okay, now recall, all students take calculus. The tangent is positive in the first quadrant and the third quadrant. Okay, since the inverse tangent is of positive 1/2, we draw our triangle in the first quadrant. Okay, recall, tangent is opposite over adjacent. Okay. Therefore, the opposite side is 1. The adjacent side is 2. Now we're going to use the Pythagorean theorem to find the hypotenuse of our triangle. Okay. So we have x squared plus y squared equals the hypotenuse squared. Okay. So 4 plus 1 equals the hypotenuse squared. 5 equals the hypotenuse squared, which means the hypotenuse is square root of 5. Okay, this is the angle that has an inverse sine or inverse tangent of 1/2. Now we want to find the sine of that. Okay, sine by definition is opposite over hypotenuse. So the sine of the inverse tangent of 1/2 is 1 over the square root of 5. Or, if we rationalize the denominator, square root of 5 over 5. Let's look at one more example. Let's look at finding the exact value of the cosine of the inverse sine of negative 1/3. Okay. All right. The inverse sine of negative 1/3. Okay. Negative 1/3 is within our given domain. Okay, but again, it is not in our table. So we're going to draw the quadrants. Okay, and all students take calculus. Okay, means that the sign is positive in the first and second quadrants. We want the sign to be negative, so it's going to be either in the third quadrant or the fourth quadrant. But the inverse sine is restricted to the first and fourth quadrant. So we're going to draw our triangle in the fourth quadrant. Okay, definition of sine is opposite over hypotenuse. So again, using the Pythagorean theorem, we're going to find the value of x. So we have x squared plus negative 1 squared equals 3 squared. X squared plus 1 equals 9. X squared equals 8. X is equal to the square root of 8, which is 2 square root 2. So x is 2 square root 2. Now, we want the cosine of that angle. Cosine is adjacent over hypotenuse. So the cosine of the inverse sine of negative 1/3 is 2 square root of 2 over 3.